Hi, everybody. We're going to do the first part of the EdX, which is lines and angles, and I'm just going to go through all 7 of these. It should take about 20, maybe a little more minutes, since I'm going to be pausing it and so on, but maybe less. Anyway, here it is, lines and angles. We start with lines, rays, and segments. And of course, we always push the play.
A line is a straight path that goes on forever in both directions. So here's an example of a line. It goes on forever in this direction, and it goes on forever in this direction. Since it's impossible to draw a line that goes on forever, lines are usually drawn with arrowheads on either end. So when you see an arrowhead in geometry, that means this continues on forever in this direction. So keeping in mind that lines are straight paths that go on forever in both directions, which of these are lines?
Clearly, it's this one and this one, of course. And we submit it.
Right, this zigzag and this curve are not straight paths, so that means that these two are the lines. You can think of lines, like this one here, as being made up of lots and lots of points. Points are usually indicated with dots, like this dot here. And here are a few more points on this line. When we talk about different points, we usually give them names that are letters. So let's call this point A, and these are points B, C, and D. But keep in mind that while points are represented by dots, points are actually infinitely small. They don't really have any size, they're just tiny specks. Because it's impossible to draw an infinitely tiny speck, we use a dot that's centered at the exact location of the point it represents. So for example, while this orange dot representing point E touches the line, you can see that point E is not actually on the line. Next, let's start with a point which we'll call P. For any given point, like P, there are many, many lines that pass through P, and here are just a few of them. But now suppose we have 2 points, P and Q. How many unique lines pass through both P and Q? And keep in mind that while we've drawn dots to represent P and Q, the points are actually infinitely tiny specks. So how many lines pass through both P and Q?
It's a really important idea in geometry, and that is that there is one line that is determined by 2 points.
Exactly. There's only one line that passes through both of these points, and here's that line. In general, given any 2 points, there's only one line that passes through both of them. Next, let's talk about how lines are named. A line can be named after any 2 points on it. So you could call this line PQ, and to show it's a line, you'd write this symbol on top of the 2 letters, with the arrowheads to show it goes on forever in both directions. Another name for this line is QP. With lines, the order of the points in the name does not matter. So take a look at this line here, with the points A, B, and C. Which of these down here are correct names for this line?
He said that any 2 points can name a line, so AB, BC, CB, CA, and AC are all on this line, and all of these are correct names for this line.
Well done! So all of these are correct names for this line. Again, you can name a line after any 2 points on the line. Points that lie on the same line, like the points A, B, and C here, are called collinear. So next, take a look at these different sets of points. Which of these are collinear? That is, which of these lie along a single line?
Looks like the yellow ones for sure, and maybe the blue ones probably line up too.
Great, so these 2 sets of points on the right are collinear, and here are their corresponding lines. So as we already said, lines go on forever in both directions, and lines are named after any 2 points with a line symbol on top of them. Now when a line does not go on forever, it gets a different name. It's called a line segment, and line segments have what are called endpoints, places where they end or stop. So here's an example of a line segment. It doesn't go on forever in either direction and stops at the endpoints C and D. Line segments are named after their endpoints, so this is line segment CD. And on top of them, you draw this line segment symbol, which has no arrowheads on either side. So which of these are line segments?
Clearly the ones with endpoints.
Right, these two are line segments. They're both straight paths with endpoints. So lines go on forever in both directions, and line segments have two endpoints. But what do you call it when you go on forever in one direction, but not the other? Well, these are called rays, and they have exactly one endpoint. So which of these are rays? Remember that like lines and line segments, rays are straight.
So clearly it's this one.
Right, this path is curved, this is a line, and this is a line segment, meaning this was the only ray up here. Let's return to names. We said that lines are named after any two of their points. So this is line AB, or you could also call it line BA. And line segments are named after their endpoints. So this is line segment CD, or you could also call it line segment DC. But what about rays, like this one down here? Well, this ray starts at E and goes on forever in the direction toward F and beyond. So this is called ray EF, and notice the symbol above the letters has the arrowhead pointing in the F direction. The first letter in a ray's name is always the ray's endpoint, and the second letter is another point on the ray. So that means FE is not a correct name for this ray. That would be a ray with endpoint F going on forever in the opposite direction. So take a look at this ray here with points C and D. Which of these is a correct name for this ray?
Okay, we can see that D is the end point. And remember, the end point is indicated without the arrow. So this is D through C forever.
Right, this is ray DC. The first letter in the name is the ray's endpoint, which is D for this ray. And the arrowhead over here indicates the ray goes on forever towards C and beyond. Next, take a look at this ray here with points R, S, and T. Since 3 points are labeled here, there's more than one correct name for this ray. So which of these names down here are correct? Remember, the first letter in the name is always the ray's endpoint.
So we want to go through either R, because if we start at S, it's not going to include R, and so this ray is the whole thing. So it has to start at R and go through S and beyond. That's okay. And it can go through from R through T and beyond. If I use this one, it would just start at S and it wouldn't work. And of course, T is the wrong direction.
Excellent work. Both of these are correct names for this ray. It has endpoint R and goes on forever in the direction of S, and you can also say it goes on forever in the direction of T. So both of these names work. Okay, last question. Suppose you have ray AB, which goes on forever in this direction, and you have ray AC, which goes on forever in the opposite direction. These two rays, which point in opposite directions and have a common endpoint, point A, together form a what? Is it a line segment, or another ray?
Well, clearly this has no end points. It has arrows on the ends, and it's a straight line, so it's a line.
Whenever two lines or rays meet, they form an angle. So here's an example of an angle. Now the measure of an angle is how much you have to rotate one of the lines so it lies on top of the other. For example, here's an angle that has a smaller measure because you don't have to rotate this ray very much so that it lies on top of this ray. And here's an angle with a greater measure. You have to rotate this ray quite a bit so that it lies on top of this ray. Now let's draw in 3 more angles. Which of these 3 angles would you say is the largest?
I'm going to call this one purple, green, and yellow. And of course, the yellow one is the largest.
Exactly. This angle down here is the largest. Now the size of an angle is commonly measured in units called degrees. So next, you'll be making your own angles and measuring their sizes in degrees. In this interactive, you can rotate these two rays by dragging their arrowheads around. The angle between them is shown in yellow, and the exact measure of the angle, in units called degrees, is shown up here. And by the way, this symbol over here means degrees. Now a single degree is a pretty small angle. Try moving these rays around to get a feel for what the measures are for different angles. When you're ready, try making an angle that's approximately 40 degrees, and then press the Submit button over here.
Be sure and try this. That's an acute angle. There's a right angle right there. There's an obtuse angle. There's a straight coming up. There's straight. And this is a reflex angle. There's the reflex angle over here. Notice that when we go all the way, if it lets us, we're at 0 degrees or 360, same thing. So we're supposed to make it 40. So let's make it as close to 40 as I can. And, almost made it. There it is.
Nicely done. So here's a 40-degree angle. Next, we'll have you make a few more angles. So try making an angle that measures approximately 90 degrees. Once you've got one, press the Submit button.
Okay, there's 90.
Okay, you're on a roll. Next, how about a 120-degree angle? 120 degrees is bigger than 90 degrees, so you'll want to increase the size of this angle a little bit.
Be sure you guys do this. Don't just watch me do it. It's more
Great.
do it yourself.
Next, try making a 180-degree angle. Right, so a 180-degree angle is the angle between rays that point in opposite directions. You'll sometimes hear that 180 degrees is the angle in a straight line, because these two rays pointing in opposite directions together make a straight line. Next, try making an even bigger angle, one that's approximately 270 degrees.
And there it is.
Well done. So now how many degrees are in a complete rotation, meaning you rotate this ray all the way around until it's back where it started? Your answer should be a whole number.
Okay, all the way around is 360 degrees. And it's going to let us. Yeah. And like I said before, it's also 0, by the way, 359, and then the next one is 360. There it is.
So here are a few of the most common angles you'll see. As you already found, 180 degrees is the measure of the angle in a straight line, and a 360-degree angle is a complete rotation. The bigger the angle, the more degrees are in it. Let's finish this lesson off by estimating a few angles. Take a look at this one. How many degrees would you say are in this angle? If you're not sure, click down here.
That looks about halfway, maybe 50.
Right, this is a 45-degree angle. Now for your final challenge. How many degrees would you say are in this angle here? Feel free to ask for a hint or two if you get stuck.
Looks like it's about 180 and then maybe halfway again. So 180 and 45 makes 225.